October 2009. Mr. Mori took the prototype to the planning team. They wanted to get their feedback about possibilities of commercialization. They first showed it to Mr. Shimada, the person in charge of developing products for the Japanese market.
It was a completely different design. The prototype really recreated the shape of the filament. I was blown away by this new approach.
But it was Ms. Muranaka who was the most enthusiastic. She was in charge of products for the overseas market.
I knew instantly that this would be perfect for the overseas market. I wanted to ask him if I could have it first.
Most of the lamps used in Japan are silica lamps. They have a white exterior. The entire surface of these lamps appears to glow. Another type are ones with transparent glass bulbs, known as clear light bulbs. The beautiful glow is magnified when reflected off objects. Approximately 80% of light bulbs used in Europe are clear. Ms. Muranaka believed that this unique glow had excellent business potential.
It was clear, so I knew it would do well in Europe. I was very sure of its potential.
We must promote both performance and design.
I think so too.
This is how the development of the LED clear light bulb began. What they wanted to achieve was an LED that looked exactly like an incandescent light bulb. So, like incandescence with a filament in the center, the LED bulb also had to glow in the center. But
Incandescent light bulbs can discharge heat as infrared rays, but LEDs accumulate heat within. So we had to think about how we can help it release the heat.
the heat must be discharged. But what makes this difficult is the clear glass bulb. It is completely transparent.
We wanted to create a clear LED light bulb to show the LED off in a way. But we didn't want to overdo it. And we also wanted to make sure that the heat is properly discharged. We needed to strike an optimal balance between the two to overcome these obstacles.
So they chose an aluminum alloy with excellent thermal conduction to create the column for attaching the substrate, successfully allowing the LED to discharge heat without sacrificing design. Next, Mr. Mori focused on developing the substrate. The substrate they created was clear. The LED emits light from this yellow portion. With an ordinary substrate, only the top glows and the bottom remains dark. But with incandescent lamps, the filament glows in all directions. So they developed a clear substrate to enable it to glow like incandescence.
I thought maybe, just maybe it's finished.
They lit it, but it looked a little strange. The reason became clear when they placed a white paper against it. The light emitted from under the substrate was bluish-white.
The color was completely different. I was very shocked.
LED's bluish light has to pass through a yellow fluorescent substance to emit light that resembles incandescence.
We had attached a fluorescent substance on top, so the color of light was right. But we didn't do so on the bottom. So yes, obviously the LED emitted blue light from beneath.
All they had to do was attach a fluorescent substance on the bottom, but the delicate design required very complicated workmanship. The team had hit a dead end. They knew what needed to be done, but they just couldn't figure out how to do it.
We kept trying, but we just couldn't get it right. There was a schedule we had to stick to, so we felt under pressure.
But 3 months later, they came across a new idea from somewhere unexpected.
I was talking about our problem to someone who was on the same team, but working on a different project. He suggested a great idea.
His colleague had proposed that they use a very unique method to paint a fluorescent substance on the substrate.
An idea that would make mass production feasible. It was a different crafting technique, so to speak.
The team then turned to Mr. Hiraoka. He was tasked with the mass production of this light bulb.
The wires used were very fine. They broke at the slightest touch. And it was very small, so it had to be handled very carefully.
But they wanted to create LEDs that were exactly like incandescents. What was driving them was their passion. February 2011. They finally succeeded in developing a unique technology, which was later named center mount technology. Everyone was very impressed by the dazzling light.
It emitted the same quality of light from the top and bottom, so we all punched our fists in the air in triumph.
At first, I saw it from 3 meters away, and it looked exactly like an incandescent.
I thought that this light bulb would have a significant impact.
Around the same time, Ms. Muranaka, the person in charge of planning products for the overseas market, frequently visited the lab. She wanted to see for herself how the light bulb would look when lit. She then made a decision.
Incandescent light bulbs in Japan, they have a color temperature of 2,800 Kelvin, but I wanted them to reduce this by 100 degrees, because 2,700 Kelvin is a European standard.
So the team decided to make the light bulb slightly yellower than incandescent lamps in Japan.
Asians, or people with dark brown eyes, we can't tell the difference so much. But research has shown that a variation of 100 degrees looks like completely different colors to people with green or blue eyes.
The new LED lamps were first made available in Europe. In no time, they began winning design awards in Germany, United States, and Japan. Their value was recognized around the world. The lamps had great potential in Europe, a market where people cherished the nostalgic glow of clear incandescent light bulbs.
This LED nostalgic clear is really modern and classic at the same time. So this is the first time, and probably this can be very much appreciated by consumers.
The moment when these LED lamps would light the world was near.